This is the third lesson from chapter 18 on integration, and today we're going to do reverse substitution. Now, normally we're given a substitution, so let me reveal this. We're going to let u equal the thing that's inside the parentheses, which is often what we tended to do anyway. Now, remember our first thing that we want to do when we have this is we want to differentiate this. So differential of 1 is 0. This one, bring the power to the front, decrease the power by 1. So we're going to get 8x cubed. Now, slightly differently this time, we don't really want to try and solve for x here, because that's going to give us something not very nice. U minus 1 divided by 2, and then the fourth root of all that. That's not going to be very nice to substitute into here. So what we're going to try and do is we're going to try and make this in terms of what we have here. Now notice that 8x cubed is pretty close to 4x cubed, and that should be the case for all of my questions. It should just be a simple multiple. So if I multiply both sides by dx, and then I can see that all I need to do is half both sides here, and then I do get 4x cubed dx. So once I've done that, I can then substitute. So all of this was a half du, so I got my half du. This was to the power of 5, so now we're just going to say that's u to the 5. And then if I rearrange this, I can bring the half to the front of the integral, as it's just a constant. U to the 5 means that's the same as on the bottom, means that's u to the negative 5. And now I can go ahead and integrate. So increase the power by 1, and then divide by the new exponent. If we simplify this, that would give us 1 over 8, and then u to the negative 4 I can bring to the bottom, and then put plus c. And then our last step should be, where it says u, substitute back for 1 plus 2x to the power of 4. So all those steps that you saw in the first lesson still are going to apply to these questions, but you just want to try and make this part, normally the numerator, equal to this part here. Now I'm going to leave this one out because a lot of students already know the integral of tan x. But if they ask you to do it by substitution, then you must do it this way. So I'm going to let u equal cosine x. If we differentiate this, then bring the dx up, then we're very close to what we have up here, sine x dx. We're just a negative sign away. So make both sides the negative of what they originally are, and then we can actually substitute in here. So sine x dx is negative du, and sometimes it's more helpful to think of that as negative 1 du. So you can actually see the fraction here. Du over u often confuses people. Now we can bring the negative to the front, and the reason we might want to do that is we should be able to recognise that integral now. 1 over u is just ln of u. Absolute values, just so we don't do any ln's that are negative. And then for your final step, substitute back for u. So that will be the negative ln of cosine x plus c. Now there's actually two forms of this that people remember, and the other one is the ln of secant x. Now the reason that works is any numbers we have at the front here, and as there is no number here, this is going to be negative 1 ln of cosine x. You can bring up as an exponent using the third rule of logs. So I could write this like that. And cosine x to the negative 1 means 1 over cosine x, and cosine x is, 1 over cosine x is secant x. So just to show you both, just in case they actually ask you to prove that the integral of tan x is this, because some people have already started to memorize this part. Now there's some good examples in the textbook that I'd recommend that you use, and then you should try the questions from 18C, questions 1, 3 and 4.